All right, well, let's talk about TROPICS. It's a very great acronym, but it's a big, long name. So can you explain to me what it stands for? And then put it in layman's terms for me after you do that.
It is so TROPICS stands for the time-resolved observations of precipitation structure and storm intensity with a constellation of small sats. Somehow that spells tropics. So yeah, what is TROPICS? TROPICS is the big word in that title. One of the big words is constellation. So what makes TROPICS different in this sense is that it's a mission. So it's a bunch of satellites. It's a constellation of satellites. It's actually 4 satellites plus one is up there actually as a pathfinder to give us kind of early look data. But it's basically 4 satellites to go up there and fly in these special orbits that allow us to effectively monitor tropical cyclones. And we can kind of do that with what we have with the satellites already. But the big difference is that with 4 and flying them in special orbits, specifically targeting tropical cyclones, we're going to get better time evolution of the storm as well. So we're going to get to be able to see the storms with a higher time revisit, a higher time frequency than we can with our normal polar orbiting satellites that we have right now.
Okay, and you say tropical cyclones, which makes me think we're not just talking about the Atlantic Basin, or are we talking about worldwide?
Correct. Yeah. So what it's actually going to do. So imagine your Earth. It's flying at what's called a low inclination orbit, which means it kind of orbits around the equator and just north and south of the equator. So it's really going to be targeting about plus or minus 30 degrees latitude, but it flies close to the Earth, so it will be going around the whole planet. It's not like what we would see on the news, like a GOES satellite, which is called a geostationary satellite. And what that satellite does, sits further out, but it rotates with the Earth. So you're always seeing the same spot over and over. So you see these fancy animations, but the difficulty with that is that they're actually much higher, further away from Earth. So you can only see certain things. So by putting these satellites lower, we can see different measurements of radiation, which allow us to not just see the storms kind of from a picture sense, but also see within the storms by looking at microwave radiation that's emitted by the Earth and the storms themselves. But we can do that. We have to get closer because there's not as much energy. The sun's this big bright thing, but we're looking at these frequencies that don't have as much energy. And so we do that lower by getting closer to Earth. And then we fly in these low orbits. And by putting 4 of them up there, we're basically able to revisit the same spot on average of about once an hour. So, but we're going all the way around the globe as well. So we'll be able to see all the different tropical cyclone basins all around the Earth, not just the Atlantic hurricane season. Okay,
so are they moving fast? If you're talking once an hour, there's 4 of them splitting the work. They've got to be moving pretty quickly.
By flying low, you're basically going it's about 100 minutes per orbit. So every 100 minutes, one of the satellites is crossing kind of the top of its orbit, which would be like plus, or the bottom would be like minus 30 degrees latitude. So it goes up there, and then the next one basically comes around an hour later. And basically in those strips of where plus or minus 30, where it keeps going over and over every 100 minutes, you can arrange the satellites that you will basically sample in those little strips, basically once an hour. And again, it's on median on average, so it's not always once an hour, but because again, the orbital configurations are a little bit different for all of them, but that's our target, is once an hour.
Could you see them with the naked eye? How close are they?
No, you cannot see them with the naked eye. This is what's actually another thing that's really interesting about these satellites, is that these are cubesats. So these our normal weather satellites are anywhere from the size of a refrigerator to a small school bus. These are cubesats, and they are literally the size of a loaf of bread. So we are putting 4 of them up there. They're smaller. They're much less expensive to build because they are these little CubeSat versions. They're it's kind of the same concept of your cell phone, right? 20 years ago, you had this computer that sat on a desk, and now you have this little phone you can put in your pocket, and that little phone can do just about as many things as your computer did 20 years ago. It's the same thing with satellite technology. It's smaller in some ways. It's maybe less reliable than the big school bus type satellites we do. But the advantage of being smaller and cheaper is that we can build multiples of them and then put them up and put these constellations where it's not just like basically twice per day like we would get with a normal weather satellite, a normal polar orbiting weather satellite. You can put them in these configurations to where you're able to basically target, and this is really a science experiment. So we're able to put them in this configuration specifically to target tropical cyclones.
Why New Zealand?
So this is actually a really interesting part of this, is that with these smaller satellites, and it's not just TROPICS, it's CubeSats are really proliferating throughout the entire space industry. So with that comes basically the need for rockets that can get our small satellites to space. And for TROPICS, not many other satellites are going to these lower inclination orbits. They're really specifically for the science. So it's a balancing act of, we need a rocket that can put our satellites specifically where we need them for science. And so the way we're doing that is through basically leveraging industry through these commercial launch providers. So it's not the traditional way of, with the big satellite, NASA would have its own launch and they would control the launch and it would be all that. This is through a process that really NASA is developing to be able to, particularly for things like cubesats, go buy an off-the-shelf launch like a company would do. It's a commercial launch. So we basically tell them what our specifications are, where we need to go, but ultimately give them our satellites, and then the launch provider puts them where we need them. So New Zealand is just one of the launch sites for Rocket Lab, the company who launched our satellite. And that ended up being, basically the optimal place for them to launch for what we needed in terms of both our orbital configuration. But another important part was we wanted to get up for the Atlantic hurricane season. So one of our top priorities was get up as soon as possible so that, we can be up and commissioned and, make sure the satellites are all working and everything, so that come, the middle of summer into fall, we have an operating constellation to observe satellites in the, basically in the North American hurricane sectors.
Yeah, that was going to be my next question. Atlantic hurricane season coming up really quickly. How immediate are you going to get data, and is it going to be useful to forecasting, to observation this season, the 2023 season?
Yeah, that was a huge priority of ours. Through this whole process, we were pushing very strongly through all the different pieces that needed to fall together, the launch and getting the launch contracts in place, getting a company that can get us up. Was really getting ready for this hurricane season. The satellites had been built. We knew we were that close. We just needed to be able to pull it off. And so really a lot of hard work, both in terms of building satellites and preparing the science, but also just, getting a launch set and getting a launch in space and all that has really happened over the last 6 months or so to get this ready to go for the Atlantic hurricane season. Because what we really, really wanted to target was, we are NASA. We're a United States federal agency. And so even though we can sample tropical cyclones all over the globe, certainly to, our stakeholders, the American taxpayer, being ready and active for the Atlantic hurricane season is obviously a huge priority. And so, the idea here is that we are also working with our partners throughout, the government and industry, to make sure that we're trying to figure out how to make this data as available and accessible to the Hurricane Center, to the Joint Typhoon Warning Center. How to make this data readily available as quickly as possible so that they can use it in their decision support process, just like they do all the other satellite data that's out there.
Yeah, I don't know. Maybe I've been living under a rock, but I feel like this is the first week I've heard of TROPICS at all. So I'm curious how long it's been in the works. How long have you been working on this?
It's been in the works for 6 or 7 years. It was selected through what's called our Venture class, our Earth Venture satellite program. And the idea of Venture is that it's basically science experiments. It's build and design something within a cost budget to do specific science. And the specific science for TROPICS was tropical cyclone measurements and really adding that time dimension, because that's what we don't have right now. So it's been in the work for, again, 6 or 7 years. I've only been technically associated with it for a year and a half when I started at headquarters. But before I was at headquarters, I was at NASA Goddard Space Flight Center. I was a weather modeler and used satellite data with weather models to improve forecasts. So I've always been aware of it. I knew as soon as the data came, I would probably, in my previous days as a coding scientist, be getting my hands on it. But now it's really a lot of fun to work on it from the headquarters level to really, see every aspect of the mission from, versus prior, I would have just been kind of a data user.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.